I'm going to now talk a little bit in detail about the blood buffer system. So the human body has several buffer systems in order to control its pH. The blood buffer system, its goal is to maintain blood's pH at around 7.4, because blood pH has a range of 7.35 to 7.45. So if we find an intermediate number, that's why we refer to it as 7.4. Understand that this blood buffer system is also known as the carbonic acid buffer system. And the reason is because it is composed of carbonic acid and its conjugate base, hydrogen carbonate. So as you can see in this graph, carbonic acid is going to dissociate into protons. The protons are the H plus, and HCO3, which is hydrogen carbonate. In other words, they also call hydrogen carbonate bicarbonate. Okay, this is carbonic acid. Now, understand that this buffer system is affected by the levels of CO2 in the body. Because in our bodies, when CO2 combines with water, that's what results in the formation of carbonic acid. So understand that if you have problems in respiration, as you can see, a decrease in respiratory rate or an increase in respiratory rate are going to be affecting the levels of CO2. And if you affect the levels of CO2, then that is going to affect this buffer system. So I want to specifically talk about a condition that is called respiratory acidosis and apply it to the carbonic acid buffer system, so we can see where the name respiratory acidosis come from. So as you can see, respiratory acidosis, as the name implies, is going to be happening when the ventilation is depressed in a system or in a human and carbon dioxide is retained. So I'm just going to highlight that. Carbon dioxide is retained. That is going to cause hypercapnia, which means an increased level of H2CO3, which lowers the pH below 7.35. As you can see, this could cause restlessness, lethargy, muscle twitching, tremors, convulsions, even coma. Okay, as you can see, other conditions are in the corner of the cartoons. But if I rewrite the buffer system that is in the previous slides, which means CO2 combines with water, and again, this is an equilibrium reaction, forming our carbonic acid. That carbonic acid can dissociate, produce protons and hydrogen carbonate. Let's explain why we utilize for this condition the term acidosis, even though it's explained that we're going to see increases in that H2CO3. So, as the first comment in the cartoon says, we're going to have an increase in the levels of carbon dioxide. So, if we relate this to Le Chatelier's principle, which we discussed earlier in this chapter, this means that overall, what we're going to have is an increase in the CO2 levels. An increase in the CO2 levels, understand that if you relate it to the table that talks about to what happens to the system, you will see that there's going to be an increase in the rate of the forward reaction. And remember, RxN is my shorthand for reaction. So that means that overall we're going to be increasing the levels of H plus in the body. If you have an increase in H plus level, as we learned earlier when we defined what pH is, an increase in protons means that now we're under acidic conditions. So what that means is that the pH level will be lower than 7.35. So this increase that we see in the H plus concentration, because that relates to acidic conditions, that's why here we consider this effects in respiratory acidosis.